So, a huge round of applause for our next rockstar scientist, Tavpritesh Sethi from IIIT Delhi.
So, dear friends, I want to take you to 2050 and three alternative realities. The first is if we take the status quo, WHO has said by 2050, if we don't take actions, we might see people start dying of common, simple bruises and cuts because of something called antibiotic resistance. Because we have taken so many antibiotics and we don't have enough more antibiotics to deal with resistance, simple infections will start killing us. The second reality is the recent Nobel Prize that was awarded for artificial intelligence in protein folding. In this world, we will be generating newer and newer antibiotics at a pace which we will be able to deal with such infections. The reality probably will lie somewhere in between. And that's where we work. We work with clinical data. What's happening to the patients? What's happening in the hospitals? What's happening in the community settings? And that's a missing piece that globally we don't have addressed enough. In the hospitals, we have something like antibiograms that tell us what were our resistances to certain drug bug pairs in the last 3 months like. But they are not proactive. They cannot tell us what will happen next. So what we do is we use these data to devise scorecards. And something interesting we found in our scorecards is that when we look at these models, these AI models that tell us what would these resistances look like, they don't go up and up and up. They follow a trajectory which has an orbit. And that's why we call it the AMR orbit scorecard. And we find that there are some locations, some hospitals, some localities where this can spiral out of control. So that's one of the key aspects. If we bring it to policy and start guiding hospitals, districts, states, countries, and even global policymakers, equip them with data science and AI solutions, which can visualize these patterns to make proactive decisions at the hospital level, at the district, state, and at the country level is what we do. We also work on intensive care unit data to predict which baby, which child is going to crash with things like sepsis, which need antibiotics in the next 24 hours, so we don't overdose patients on antibiotics. So if we have to really deal with these kind of threats, we need three things. We need good data. We need people who can understand these data, both from the lens of data science and the clinical medicine and biology. And thirdly, we need insights that people can understand, policymakers can understand, journalists can understand. And that's what my lab does. Thank you so much.